Hey Ross, in Unit 5, we're going to start looking at sinusoidal functions. We're going to take our trig operations from the last unit and make them outputs to create functions. But first we want to look at periodic functions. These sinusoidal functions that we're going to look at are an example of periodic functions. I'm going to be just walking you through the entire lesson for 5.1 because there's a lot of new terms and we want to make sure, or familiar terms that maybe mean something different in math, and we want to make sure everyone's on the same page. So let's imagine we have a cutting blade and an assembly line. It sits at a height of 0.5 centimeters, takes the blade 1 second to perform a cut by falling and rising again at a constant speed. It says the cuts are 4 seconds apart. We could make this clear and say the beginning of the cuts are 4 seconds apart. So we're asked to sketch the relationship of height versus time for 15 seconds, assuming the blade is starting a cut at 0 seconds. So if it's starting a cut at 0 seconds, it would be at its initial height of 0.5. And then it says it takes 1 second to perform the cut by rising and falling. And I'm going to assume that it goes all the way down to the actual height of the surface, and then back up here at the end of 1 second, doing so in a continuous manner, and that's why I'm drawing a solid curve. And then if cuts are 4 seconds apart, I'm not going to be performing the next cut 4 seconds later. I'm going to say that the start of the next cut is going to be 4 seconds later. That's, again, a little bit ambiguous here, and that's not the kind of thing I want you worrying about on a quiz or on a test. So let's say that cut is beginning right there. So this is the pathway that the blade takes. Well, although this is time, the blade's not going to the left. The blade goes down and then up and then stays at that height for about 3 seconds. Then it goes back down and up, down, up. I think I wrote this question after watching a YouTube video on licorice or something like that, and just saw the blade going down and cutting the licorice as the licorice passed on. Now I'm hungry for licorice. There we go. That's the start of 8 seconds. Next cut will start 12 seconds on. Here we go. And so if this feels a little bit repetitive to you, then you're getting one of the most important points of this lesson and unit. Many functions can be repetitive. Many real-world application functions we want to be repetitive. We want daily temperatures to repeat. We want pressure inside of a canister to repeat. I don't know. I'll call this the height curve H. Okay? All right, now onto the questions. First question says, is this a function? And explain with specific variables. So I'm taking a look at this and I don't think it would ever fail a vertical line test, but I want to use specific variables and explain based on the situation, not so much just the graph. So I'll say yes at any possible time. That's a set of any input, any possible input. The blade, there we go, can have only one height. Good. If this relationship were not a function, then that would mean at some time the blade is at 2 possible heights, and that doesn't make any sense. Part C says, identify the repeating part of the graph, and this can be done in a couple of different ways. It all depends on your perspective. Some people might see a bunch of, I guess these would be trapezoids repeating. Other people might see a bunch of sort of square root symbols or radical symbols repeating. Other people might see some backwards radical symbols repeating. It doesn't really matter what you consider to be the repeating part, as long as you go from the beginning to the end. And then I suppose maybe we should be exclusive on one of those cases, because like that point right there, if I'm considering this point to be the start of the second cut, it shouldn't also be the end of the first cut. But again, I'm making a big deal of something that's not too important. What is important here is the name for this thing, this actual pathway that the curve is following. We call this the cycle. Okay. If you're familiar with, well, you should be familiar with this idea from grade 9 health class, the levels of hormones in the human body. You may use the word cycle to refer to an actual length of time instead of the actual passage of, oh, this is the height of whatever hormone it is we're tracking in the human body. But in mathematics, we call the physical pathway the cycle. So it doesn't have a number attributed to it. You won't say, oh, the cycle is 4 seconds or the cycle is 0.5 centimeters. No, it's just the shape itself. It's useful in discussing other definitions, but we're not going to assign a number to it. It says identify the largest, it says y value. Let's fix this. This should be dependent value. In this case, height. This is called the maximum. Unlike quadratics, this maximum height actually repeats over and over again. It is specifically 0.5 centimeters in this case. The smallest output or dependent value, let's just mix it up and call it the output. This is called the minimum. This is kind of unique because this is the first relationship that we've seen, perhaps other than maybe a circle. It's the first function, let's say, that we've seen that has both an absolute maximum and an absolute minimum, a highest possible value and a lowest possible value. These maximae and minimae are values, not points. Okay? If I ask you, what is the highest that this blade ever reaches, you're not going to say 0, 0.5. If I say what is the lowest that this blade reaches, you're not going to say 4.5, 0. Okay, a lot of people and even some textbooks and some websites will call 4.5, 0 a minimum, but it is not the minimum value. When we talk about minimum values, we want the outputs. Our minimum height, in this case, is 0 centimeters. It says draw a line halfway between the maximum and the minimum. It's not going to be that useful in this application here. Let's have a look, see if I can do this. Halfway between there is going to be at a height of 0.25. In sinusoidal curves, this axis will be much more interesting. For our situation right now, it's really just a halfway point. That's the line, I guess, y equals 0.25. That's called the axis of the curve. In this case, the axis of the curve is y equals 0.25. It is an axis. An axis is a line. Lines have equations. It's not just a value. It says find the distance between the axis of the curve and the maximum or the minimum, also known as half the range. So I can do 5 minus 0 is 5, divided by 2 is 0.25, or 0.5 minus 0.25, or 0.25 minus 0. However I get that, I get 0.25, which is the same as this value here. Bad example. A lot of our examples today actually have a minimum of 0, so you'll see this happen a bit, but it's not always the case. This is the amplitude. I'm not sure how many of you still listen to the radio. I'm sure most of your vehicles have a radio in it. When you are changing channels on the AM dial, you are modulating your amplitude. You're changing what kind of wave your antenna is responding to, what kind of signal it picks up. And these different stations broadcast their signals, I suppose, at different amplitudes. Measure the time between the cuts. Well, we were just told what that was. That was 4 seconds in between the cuts. This is called the period. And again, in a grade 9 health class, you would probably refer to the period as the event itself, I suppose. The process of the changes going on in your human body. In math class and science class, we refer to the period as the change in the independent variable. I think this is defined on the back, but let's get it out of the way here, because this is the one. Period and cycle are the ones that people usually get mixed up. Change in the independent variable over, one complete cycle. Okay. Think of the cycle of the moon as just the process of it going from a full moon back to a full moon. The period would be about 28 days. Okay. The period isn't the event of the moon being full. The cycle isn't how long it takes. You can talk about one lunar cycle is 28 days. You're actually saying the period of a lunar cycle is about 28 days. And I think I'm a little off. It's like 28.5 or something. I don't know. Ask a scientist. Okay. Let's define these terms on the back. There's some kind of ridiculous fill in the blank stuff here. A function whose, again, let's just fix this and make it a little bit more generic. I've been meaning to do that permanently for a while. A function whose, let's just say, outputs repeat over a constant interval of the input is called a periodic function. Now just be very careful. When someone asks you to define a periodic function, don't tell them that's a function that has a period. Because if they ask you what is a periodic function, they probably want to know what is a period and what is a function. Okay, if you ask me what is an asymptotic logarithm, I wouldn't say, oh, it's a logarithm with an asymptote. That, if you don't understand the words I'm asking you to define, me re-explaining it using those exact same words isn't helpful at all. But when you have a situation where your outputs or your dependent variable repeat over a constant interval of the independent variable, and your outputs, any possible input yields exactly one output, then you have a relationship, which is a periodic function. The repeated part of the function is called the cycle. That's really just a part. It's not a number. It's one of the few things here that isn't a number. The change in the independent variable over one cycle is called the period. And I forgot to mention, we generally use capital T when identifying the period, because that will usually be a number. It's not always time. It can be a distance. It can be, it's almost often time. It can be a length, yeah. The largest, switch this, output on the graph is called a maximum, or the maximum, I suppose. The smallest output on the graph doesn't even need to be in the graph. It's in the relationship. It's called a minimum. The horizontal line that includes points halfway between the maximum and the minimum is called the axis of the curve. The equation of such a line is called the equation of the axis of the curve. The distance from the axis of the curve to the maximum or the minimum, or half the range, is called the amplitude. If you have some familiarity with physics, you may feel like we're missing a quantity called the frequency. We don't really need to worry too much about the frequency in this course. For specific types of waves, you may be interested in the frequency. And when you're changing your radio settings on the FM dial, you are alternating your frequency. It is inversely related to your period. Okay. Why don't you try question 2 out? Answers are available on the file that I posted to the classroom, and then we'll get practice with these terms outside of non-sinusoidal situations very soon in lesson 5.2.